NASA is famous for its exploration and exploration in space. However, the agency is also making discoveries underground, right here on our planet. One of them is a strange new discovery. Under the Antarctic ice, it's changing the way scientists look for the Earth. So what did NASA discover? How it all affects us. Very few of us consider Antarctica a dream destination. Yours, and that's understandable. Antarctica is the 6th largest. It has an area of about 14 million square kilometers. This size varies by season. As the fat ice widens along the coast, will almost double the size of the 6 sites. In the winter, almost all of Antarctica is covered in ice. In fact, less than 0.5% of this vast wilderness. There is no ice. It contains 90% of all the ice on Earth. In an area that's only 1.5 times the size of the United States. Antarctica is so cold, if you throw boiling water into the air, it'll evaporate immediately, because most of the particles will turn into steam, while the rest immediately turned into small pieces of ice. 6 areas divided into 2. It's called East Antarctica and West Antarctica. The South Pole covers 2/3 of the world. It's about the size of Australia. That's equal to this part of the 6-mile average. West Antarctica is a series of frozen islands. To the southernmost tip of South America, it forms an extension of the Andes Mountains. 2 areas separated by 2 Transantar Mountains. It's spread across 6 continents and is sometimes covered in ice. Absolutely. Do you think there's plant life in Antarctica? Of course there is, but it's limited to a few lichen moss and algae. Moss cover seasonal in Antarctica has risen steadily over the past 55 years. However, animal life is much richer, even though there are no amphibians, reptiles and land mammals. But there's a lot of whale penguin populations here. Fish and animals without spines, thriving along the coast, and the cold waters of Antarctica, especially in the summer. And human life on the strip. This large ice is okay. There's no indigenous people in Antarctica due to inclement weather, but you can find up to 4,000. Scientists come to work in 70 research stations, save despite the cold on 6 places in the summer. It's down to 1,000 in the winter. It's even harsher. The 5 poles are mainly the center of climatologists, oceanography and marine biology. However, frozen melt is also collected, suck those who love astronomy, from all over the world. This is because if you can stand the cold. The South Pole, it's one of the best places on Earth to observe space. This is because of the dry climate, and there's no light pollution. Talk about space tracking. NASA is now the leading agency in the world. But what NASA has been doing in Antarctica? Looking down from above, you might think the Antarctic ice sheet, it looks like a perpetual blanket of ice, has covered Antarctica for millions of years. But don't be surprised that the longest ice can go thousands of meters in height, contains hundreds of lakes of meltwater at its bottom, contact with the rock base of 6 places. Now by using laser equipment, the most advanced Earth observation NASA has ever made. Once launched into space, the scientists have improved their maps of the system's hidden pool under the ice in the West Antarctic, and discovered 2 more lakes under the ice that are active. It's called Conway and Messenger. The new study provides an extremely important insight to detect the lower lakes, new ice from space, and assess this hidden water system. How does it affect the speed of ice? Into the South Atlantic. More fresh water, it can change the flow and its ecosystem. With the Cloud and Ground Ice Altitude Satellite, it's called NASA's ISAT-2. The scientists were able to accurately map lakes under the ice. Satellites measure the height of the ice surface, even though it's very thick, but they rise or fall as the lakes fill up, or wide drum under the ice. The study was published in the journal Geophysical Research Letters. Altitude data integration from the predecessor of ISAT-2. Original ISAT mission and satellite CryoSat-2 of the European Space Agency monitor the thickness of ice at the poles. Hydrological systems under the Antarctic ice sheet. It's been a mystery for 10 years. That started to change in 2007, when Helen Amanda Fricker, glacier researcher at the Institute of Oceanography, script from the University of California, San Diego, has made a breakthrough that's changed understanding. Classic of Antarctic subglacial lakes. Using data from the original ISAT in 2007. Ricker first discovered that beneath the fast-flowing ice of Antarctica, the whole network of connected lakes, active filling and drainage over time. Previously these lakes It's believed to be able to keep water flowing without filling and draining. ISAT mission was originally thought to have discovered the lake systems connected to each other at the bottom of the ice are moving, surrounding water. It allows scientists to study all the impacts on the state of biology and oceanography. But with InSight 2, the scientists had a powerful tool, deliver data with such high accuracy that they can start to map out lake boundaries on the surface. The scientists, it's a theory of water exchange. Under the ice in Antarctica, it's the result of a combination of factors, including the fluctuation of pressure due to the large weight of the ice above, friction between the ice and the rock below, and the heat comes out of the ice. The earth below is insulated by the thickness of the ice. It's a stark contrast to the Greenland ice sheet, where the lakes at the bottom of the ice are filled with water, melt through the cracks and holes on the surface. What's going on deep below the surface are the lakes Conway and Mercer. The mystery is contained in this cold water village. It's hidden under 2 to 4 kilometers of ice. On the 6 south poles, they fill up and they're gone. Time and time again, according to the cycles, their part can affect the speed at which the ice moves, as well as how and where water melts to the Southern Ocean. In exchange for flow, that can change ocean currents in the Southern Ocean, and is capable of affect the retention of the world's oceans. Unlike most lakes on the face, it exists in one place for many years. This groundwater system is dynamic, or has high liquid properties. By combining the data from multiple satellites from 2003 to 2020, the scientists were able to monitor changes in the lake system under the ice between those years. They focus on the 3 areas that have coverage. Good satellites and lakes are working. Know the boundary between the currents. Master and Williams in the southwest. Mark Eel Flow. Lower also in the West Antarctic, and the Academy above in the East Antarctic. At the boundary of Master and Wilson, the researchers found 2 new lakes that they named the Lower Conway Subclassical Lake and Lower Lake Master Subclassical. They also discovered that what's supposed to be a lake under the ice, it's actually 2. Over time, these lakes undergo major changes. For example, households below the ice line Master and Williams have gone through at least 3 stages of drainage. 17 years in the meantime. All the households below the marked AL line all follow the drainage model and fill their own. The bottom lake has experienced 4 events, filled during the study period. Each event takes about a year to complete. The second lake ran dry from 2014 to 2015. It has been filled back, while the third lake is just running out of water from 2016 to 2017. Meanwhile, the households below the river Academy ice ran out of water from 2009 to 2018. All of these changes are pieces in the picture of scientists, an understanding of the speed and direction of ice flow. Current South Pole. The researchers are looking for the connection between the lakes under the ice and the ocean. In 2000, not 201, another study has found that the drainage of a lake on the Emery ice shelf in the East Antarctic has happened to 750 billion liters into the ocean in just 3 days, according to Life Science. Although it's interesting when you find lakes buried deep under the ice in Antarctica, but a question that you can ask is whether there's life in that lake or not. The environment on the surface is harsh enough, but can life survive deep beneath 2 newly discovered lakes? Expedition leader, Professor of Polar Ecology at the University of Montana. Answer that. Early studies of water samples taken from the lake Master shows they contain about 10,000 bacterial cells per milliliter. Although that's only about 1% out of 1 million V cells. Creatures on each milliliters are commonly found in the open ocean. But it's still a worthwhile discovery. Pay attention to a body of water. No sun, the sun is buried deep beneath the glaciers of Antarctica. But it's not the end, because high level of microbial life in the lake, dark and buried deep. It's a sign that it can help higher forms of life, such as microscopic animals like water bears. Meanwhile, the abundance of microbial life in the lake. The Master reflect the discovery of high levels of microbial life at Lake Williams under the ice near the South Pole. In 2013, on an expedition that John Preschool also lead, scientists hypothesized that bacteria in the lake Williams and maybe the Master Lake are surviving on carbon deposits made by photosynthetic organisms 500 million 10,000 years ago. When the lakes are buried, it can be connected to the ocean. During their time on the ice, since mid-2000s, not 102, the expedition used a drill and hot water to open a drill hole from their camp. On the frozen surface, the liquid lake gun is buried. Drilling team drilled through 1,068 meters of ice, and the water below is minus 0.65 degrees Celsius. So that scientific researchers can sample the water and sediment cores from the lake at a depth of 15 meters. At that point, the team also lowered a vehicle underwater. Dedicated is remotely controlled down into the dark waters of the lake, buried as well as some of the cameras they used to take a picture and shoot the levy back to the bottom of the lake. This finding has implications for the search for life on other planets, especially on the planet Mars, where the signs of a lake of liquid salt water, buried, has been seen in data reported in 2018 by the European Space Agency's Mars Express spacecraft. In fact, John Priscool think that any life beneath the frozen surface of the planet Mars can all follow the models seen in the lakes under the ice in Antarctica.